Hello, I'm your host Ayush Chaudhary and welcome to a lecture series of ACM student chapters. Today we will be discussing about processors and the history of processors and how they evolved and some context about computer architecture. And also before that we will have a small news section where I will tell you about the latest news in the tech world. So the first exciting news we have is the release of Raspberry Pi. It released about a month ago, and it is available in two versions, 8 GB and 16 GB RAM. So it is a really exciting news for all the Raspberry fans. And also the release of DALL-E 3. I will just put the link there. And also I played around with stable audio. The audio which I received were intermediate. If you are able to make better sounds or songs, do let me know. And now we will start with the lecture.
If I go straight into it, there are two types of architectures that we know. The first one is von Neumann architecture, and the second is the Harvard architecture. But before we get into it, let me start with more basic thing, and we have to go back to 1930s when Alan Turing. He, along with his friend Alonzo Church, they started the field of computer science. So basically, what they said is, whatever problem. So this was their initial statement. Whatever the problem that you can solve in any kind of computer, the hardware computer, you can also imitate that in a Turing machine. So we have two types of architecture: von Neumann, and the second one is Harvard. So von Neumann architecture involves two components. The first one is the processing unit, and the second one is RAM, the storage, obviously. So in von Neumann architecture, your programs and the data both are stored in RAM. But in von Neumann, your data is stored in a separate storage, and your executables or your program files are stored in a separate storage.
So, Aman, can you tell when the first time processor were commercialized?
Yeah. It was commercialized in 1971 by Intel. So it was called Intel 4004, and this 4004 has to do with the architecture of it, because it was a 4-bit architecture. Currently we are using 64-bit, but it was initialized with 4 bits, and it was a challenge given by the company named NCMC, quite complicated name. It was the challenge given by them in 1969, and Intel completed it in 1971, and later they got the rights from NCMC and renamed it as MCS4. So this was the name of the chip that they developed. So yeah, let's get into how the processor works, right? So the processor, when we talk about the processor, it is accompanied by a storage, right? Because without a storage, the processor is as good as nothing. So you have your RAM here, right? But your CPU doesn't know which instructions to perform, right? So then comes the point of instruction pointer. So what is the instruction pointer? Instruction pointer is used by CPU to point at a particular address in which the instruction is stored. So suppose this is your storage, and these are different addresses, right? So your current instruction pointer is here. So basically, whenever this pointer is at a particular address, and here we have the instructions, this will fetch and give to the CPU.
So the data which is stored here is just the memory address, right?
Yeah, it's the memory address. and whatever the machine code is in this particular address will go into CPU, and then CPU starts executing it, right? So it is execute, and when the code at this particular address goes to CPU, and when the CPU is executing it, your instruction pointer IP moves at a different location, at a different address, and this cycle keeps on going, and we call this as fetch execute cycle.
So the pointer is just iterating to on the all the instructions.
Yeah, basically, yes. So whatever instruction you first stored in the storage will get executed on a priority basis.
Okay.
Yeah. So yeah, so this was the thing, but you might wonder like, what is this instruction pointer? How it is, what it is, because CPU is using it. So CPU doesn't create it in the air, right? It uses something called as registers. So your IP instruction pointer is implemented using registers. So what are registers? As the name suggests, registers store memory, but there is a difference between RAM and your register, because register holds temporary memory. And if I get into more detail, as I'm a physics student, registers are made of flip-flops, and there are many kinds of flip-flops, JK flip-flops and all those. But yeah, a flip-flop is a digital processing unit which handles 1 bit. And if you want to have a register of n bits, you will use n flip-flops.
Okay, so register is a part of CPU or RAM. So
basically, register is a part of CPU.
okay.
And we can say that we have many kinds of register, but we have access to some of them. We don't have direct access to some of them, and those which we have access, we can randomize it. We can say that okay, we can operate it, but we cannot direct fetch their values.
Okay.
Yeah. So this was about registers. So you might again wonder, okay, we talked about the instructions. So what are these instructions? Let's get to it. So these instructions are what we call as programs, right? So obviously we write program in Python and C++ and Java, but you know that some of these are high level languages, some of these are low level languages, but the instructions are always in zeros and ones, binary. So but we have a language which is not as high as Python and as low as not as, obviously you won't work in binary, but you can work in a language called assembly, which is easily convertible to machine code, but gives us nice essence of what is going on in the processor. So the assembly basically divides the code in two parts. Which first one is operation code, also known as OP code, and the second is your operands.
So the data on which the code will be operated
Exactly.
on.
Yeah, exactly. So whenever this particular instruction, now this is instruction, it goes into CPU. The first thing is OP code, operation code, and this tells the CPU which particular operation to perform, and operations to perform on these operands. This is the data on which that particular operation will be performed.